Hello, I'm Anna Mackay, and this video is on reciprocal functions. And it carries on from the work that we've been doing on the direct proportion, those types of functions and graphs. So, reciprocal functions are of the form where y is equal to k divided by x, where k is not equal to 0 and is a constant. So what would the graphs of these look like? They are also referred to as a rectangular hyperbola. Fancy talk there. So graphs here where k is greater than 0, and as you'll notice we've got two parts to this graph, one on either side of the y-axis and the particular shape that they follow there. And we say that that is asymptotic there. So the one on the left there is when k is greater than 0, and the one on the right here, you may work out, is when k is less than 0. So notice it's the similar shape, but they have rotated from either side of the y-axis there. If you were to think about what the coordinates would be for each of those two graphs, it would become obvious as to where the graphs would have to be placed due to those coordinates. Okay, so both functions have horizontal and vertical asymptotes. Have a think about that. What are the equations of these asymptotes? So thinking of, we'll do horizontal first. So a horizontal line, think about what the equation of a straight horizontal line is. They're always going to cut through which axis for a horizontal line? A y-axis. And so all horizontal graphs that cut through the y-axis have the equation of y equals. But in this case, so we're after the asymptote. So we can see that the asymptote is here. It's the actual axis. So that's the x-axis. And what is the y-coordinate at the x-axis? It's 0. So, oops, I've done the next one. So I've said that y equals 0 is the horizontal asymptote. And the vertical asymptote, same concept applies, that vertical lines are all x equals, because it's the value where it cuts through the x-axis there, whatever that number is. And for these graphs, the vertical asymptote is when x is equal to 0, and so that's the equation of the asymptote. It's useful to determine points when drawing a sketch. So for example, if we have the graph y equals 1 on x, then this is what the graph of that would look like. And thinking about when you substitute in, if you had x is equal to 1, you'd have 1 divided by 1 there to give you the y value of 1. Same for the negatives. The general case of y equals k divided by x for any constant k other than 0. Interesting to note here, two of the points that I guess they're alternating. So you see here the x coordinate is 1. So you're imagining if x was 1, you'd have k divided by 1. That gives you k. So the y value is k. And vice versa, if y is equal to 1, you would have that equation. You rearrange, timesing through by x, so you'll get x is equal to k. And hence the second point that we're dealing with there. Also worthy to have a think about, if you had to find k, what the k value was, that you could take any of the coordinates on the graph, essentially multiply them together. So what I'm getting at is that if y is equal to k divided by x, k is equal to x times by y, or yx, whichever way around. So that you could multiply in one point the k value, the x and the y coordinate together, and that would give you the k value. That'll come in handy for some of the questions you're going to do. Okay, if you like that, subscribe to the channel, and the next video in this series is 1D rational functions. Thank you.